Hi, I'm Meta Spencer. Let's go to the Arctic today, shall we? Vicariously, thank goodness, because I have no desire to go up there in the flesh. Unlike my friends who seem to really be experts on northern affairs and don't mind getting cold from time to time. My friends are actually, I have two experts with me. Professor Stephen Salter, who is an engineering professor at the University of Edinburgh, a retired man who's been working on developing a nozzle to spray seawater, which we will get into in a bit. And in Turin, Italy, is Professor Peter Wadhams, who is one of the world's leading authorities on Arctic sea ice. And they are going to help me understand some, here comes Paul Beckwith as well, joining us. Bless his heart. Paul Beckwith is a Canadian climatologist who knows his way around the Arctic and climate affairs as well. Hello, Paul. How are you?
Hi, I'm good, thanks.
Good. You're in outer space today. Good for you.
Yes.
Okay, and we are going to be doing something a little different today. We're going to be talking about a particular proposal that I am going to be pitching, if you will, to the Canadian Pugwash Group, which is an organization that I've belonged to for 30, 40 years, maybe more. And this is a project that I'm hoping that the Canadian Pugwash Group will agree to investigate more closely, with the idea that if the organization and the committees investigating it agree that it's a worthwhile project and affordable and not too risky, then they will collectively try to encourage the Canadian government to take it on as a measure to reduce climate change on the planet. So in preparation for my conversation proposing this to the Canadian Pugwash Group, I've invited any Canadian Pugwashites who want to do so to join us today by Zoom, so that they can also participate in the conversation and ask questions, especially of the experts that I've invited, who are in a position to answer these questions much better than I am. I am not a scientist and can't begin to pretend to answer most of these questions, but I have had a number of conversations with all three of the experts who are with me, Stephen Salter, Peter Wadhams, and Paul Beckwith. So I am familiar with the idea enough to believe personally that it's a promising solution that should be worth exploring. And I think if we explore it further, I think probably other people will concur with my judgment that it's worth maybe actually attempting on a major scale. So here's the basic idea. Professor Salter will be able to explain how this works in a bit, but it seems that if the clouds surrounding the Earth are white, they reflect light back into outer space and less light gets through to warm the planet than would be the case with dark clouds, which, as we know, rain clouds are dark and heavy droplets of water, but white clouds have tiny droplets. So the idea is to change dark clouds into whiter clouds, and you can do this over a particular area so that the surface of the planet below is cooled, thereby kept cooler. So if we do this over the Arctic, it is possible to cool the Arctic Ocean or any other body of water that's underneath. This is not something you would do over land because there are too many other contaminating factors over land. And besides which, you probably want your sunshine to come in and be available for agriculture on land, but that's not the case so much over the water. So the idea of this proposal is let's take Hudson Bay, which is one of the only bodies of, at least it's a large, large body of water that is contained entirely within Canadian territory, and therefore Canada alone can make the decision about what to do there. And let's cool Hudson Bay by spraying seawater into the atmosphere, into the clouds rather, above Hudson Bay, and cooling it. And you can cool it enough if you spray it right with the right kinds of droplets. You can cool it enough to keep some of the ice on the surface of the water throughout the summer. I suppose you could keep all of it frozen if you sprayed enough, but we don't need to do that much. Let's do enough to retain some of the ice that is going to be desired by the native people living around the shores, because they make their living by going onto the water on ice and hunting and fishing and so on. So it's their lives are very hard right now, and the wildlife and the whales and rather the seals and the polar bears and so on are in trouble. So we need to do something to preserve the ice on Hudson Bay. And my proposal is, let's see if we can't do that. And Stephen Salter is the man who would be able to put such a project into effect. And we have with us Adele Buckley. Dr. Adele Buckley is a physicist and a longtime member of the Canadian Pugwash movement, where she's taken a leading role for many years. She was on the International Pugwash Council for a number of years, and she is a physicist who has done work especially on water issues, and but also has been engaged with all of the concerns about nuclear weapons that the Pugwashites have focused on, and has been very engaged with studying and promoting the notion of nuclear weapon-free zone in the Arctic. So good morning, Adele.
Hello, everyone. I'm glad to be able to talk to you. And I want to say that I have a career experience of quite a number of years in commercializing new technologies in the environment, and that may apply to our discussion today.
Yeah, indeed. You know your way around the business end of things. Thank you. Okay, Stephen Salter, did I mislead anybody with my little introductory pitch? And if in any case, I'd like for you to pick it up and go forward with that. I see that we have a newcomer joining us, Evner Tara.
We need a few numbers, first of all, and the recent estimate of the climate problem is that we're retaining about 1.7 watts per square meter of the Earth, too much. Okay, 1.7 watts is a rather dim light bulb, but there's a lot of square meters. Now, the solar input coming in from the sun, if you average it over the whole world and the whole 24 hours, that works out at about 340 watts per square meter. So if you can do the arithmetic, you'll see that our problem is just 0.5%. Okay, 0.5% of the sun too much. Now, it's uneven, of course, but that's what the total average is. Now, the reflectivity of clouds ranges from about 75% to about 25%, which would be quite a dark cloud. So the swing of reflectivity of clouds is far more than we need to solve the problem. And there was a chap who was very interested in the cloud reflectivity when they found funny long streaks of cloud after where ships had been. And his name was Sean Toomey, and he was able to get airplanes to fly over clouds and measure the power coming down from above, from the sun, and the power coming up from below. So he was able to measure the cloud reflectivity. And he was also able to fly into the cloud and scoop up the drops and see how big they were and how many of them the concentrations were. And he did lots and lots of work like this, and he produced the results, which boil down to the fact that the cloud brightness depends on the size distribution of the drops. And if you have a lot of small drops, you get a white cloud. If you have the same amount of water in a larger drops with a smaller number of them, then it's dark. And you probably really knew that already because you've heard people say the dark storm clouds are gathering. Mm-hmm. And his work has been replicated and it's accepted. And you can do a lovely pocket demonstration here of 2 jars of glass balls. Mm-hmm. These ones here are 4 millimeters in diameter and they look a bit gray. These ones here are 40 microns, 100 times smaller, and you can see that these look white. Mm-hmm. Okay, so there's no concerns about that. Well, then next thing you need to know is that you can't just get a drop forming in a cloud just because the relative humidity has got up to 100%. It has to be a little bit above 100, and the amount by which it is above that was studied by a chap called oh God, that's my age. It'll come to me in a minute. Kohler, and he worked out how much extra humidity you needed for different sizes or different weights of condensation nuclei, which you need to get the growth of a drop started. And you can't just have a drop forming from nothing. It has to be given something to begin with. And if you have rather small nuclei that you've squirted out, then the size of them varies according to what the local humidity is. And if it's above a certain peak lump, you can get over this and then it'll grow without any limit at all, and you'll end up making a raindrop. And John Latham, who's another chap, knew all about Kohler and he knew all about Toomey, and he thought that maybe we could increase the number of condensation nuclei and enough to get a larger number of smaller drops. And he worked out all the calculations from Toomey's equations, and he was amazed at how little water you needed to solve the climate problem. And it was really about 10, maybe 20 cubic meters of water a second if you could spray them with very, very small drops. And what would happen would be that the small drops would evaporate, they'd leave a tiny little salt crystal, and Kohler says that salt is almost the best condensation material that you can get to make a new cloud drop. So the idea was to spray to increase the concentration of drops in clouds over the sea. You can't do it over land because the air there is already so much dirtier that you can't really add any more nuclei. There's there far more than you need. And at the time, I was working on a way to try and make the sea evaporate faster by trying to increase the area available for evaporation with a spray. John Latham heard about that, and he telephoned me and said, "Can you make the spray for my project?" And I said, "Yes, I think I can do that." I didn't know how hard it was going to be, but I was overconfident. And this was in 2004, and I've been working on the engineering of how to do that more or less full time since then. And now
the idea is you need to make a nozzle that will spray finer than any living creature has ever invented before. Is that it?
No, the viruses are smaller than this. The size of salt we want to make is 10 to the minus 14 grams, and a COVID virus is about a tenth of that. Mm-hmm. And we will be using technology which was developed to filter seawater to get rid of polio viruses, which were about 30 nanometers. So there are living organisms that are smaller than this.
Okay, now here's my notion of what the game plan is. We would ask the Canadian, if everybody finds that this is a reasonable thing to do, we would ask the Canadian government to fund a situation where you will finish developing this very special kind of nozzle so that you can spray seawater. And we will set up stations, like 4 different places around the coast or the shore of Hudson Bay, where the seawater has now, the ice melts throughout the summer now, and it causes a lot of trouble for the indigenous people. So we will ask the indigenous people where they would like to have this ice restored, and set up places on the shore spraying seawater over the Hudson Bay into the clouds, so that we cool the water and retain some ice on the bay where they want it to be throughout the summers. And of course, then it freezes in the winter. And as I understand it, you think that it would cost something like $30 million to do this.
Yes, I think we could, especially if we could do it from land rather than at sea. Eventually, we want to do it in the Middle Pacific, so we do want to do it where there's clean air and where we can take ships. But we could do some experiments if we've got a place where there's clean air coming in, and we can add our aerosol to it. Making the ships is a bit more expensive than $30 million, but we wouldn't need to. We could learn some useful stuff without that.
Well, I think also the idea is that this would be, in a way, a demonstration project, because if we can show that it can be done on Hudson Bay, it can also be done in some places or throughout the entire Arctic Ocean. And that's too big a project for Canada alone to undertake. But if it's demonstrated to be workable, then other countries may collectively join together and attempt a much bigger project there. Is that?
Yes, that's right. The key thing is that the people who live there have got to decide how much ice they want. And if they decided that they don't like it, they'll tell us to stop. And in a few days, in the next time it rains or snows, that the cooling effect will fade away. So very, very soon you'll be back to where you would have.
Okay, good. Okay, can we go on now and ask Peter Wadhams's thoughts about this, and then I'll get to Paul Beckwith to comment on what we've decided so far. Peter Wadhams is an expert on Arctic sea ice, and so tell us why that might be desirable, or what might be some of the risks or costs or dangers or downside, if there are any, for such a project.
Well, I think one of the main problems that people have identified about the Arctic is the fact that we really don't want the ice to disappear. We want, because it is disappearing, and that's bringing about some really serious consequences for the planet involving thawing of permafrost, rising of sea level, a whole kind of gigantic horror film of things that are bad that are happening because the sea ice is disappearing. So a strong need is to stop the sea ice from disappearing, to bring it back, or cool the Arctic to the point where it doesn't disappear, and can therefore supply a permanent presence in the Arctic. Now, the difficulty of doing this is that most of the methods that people think of to do it are impractical and or can't be scaled up to the scale that we need for keeping the entire Arctic cool or cold or frozen. And some of them are actually, well, one could say bonkers, but there's there are a lot of ideas which do require checking out on a large scale, and the one that is I think most promising is this one which Stephen's been talking about, marine cloud brightening, because all the other techniques talk about really trying to keep the surface of the Earth frozen, and but marine cloud brightening is really consisting of simply trying to cool the atmosphere, and to the point where you don't have the kind of melt and rapid melt, which is going to cause all of these really terrible effects. So I think it's a very good way to proceed, and to try and put in a lot of experimental work on a large scale, which is needed to see if we can actually make this work. I mean, Stephen's work has been so meticulous over the years that really one can almost, one can see what is going to come out. And if one can see what's going to come out, and what's going to come out is actually something that really will help to preserve the Arctic, then this makes marine cloud brightening something that really should be proceeded with a high priority. It's amongst all the spectrum of ice preservation methods that have been suggested. This is, I feel, the one that is most sensible and most likely to be successful. So I think I would say we should go on that with high priority.
So this seems, let's reinforce a certain point, which I think is that almost all of the other measures that have been proposed as ways of cooling the planet involve the reduction of carbon from the atmosphere. Now, this is one of the technologies that will not reduce carbon from the atmosphere. It's going to actually cool the planet directly by simply shading the planet. So it's not going to do a single thing in terms of reducing the carbon. We have to handle that in other ways, and we are handling it in other ways, or at least maybe not as fast as we should, but we know what to do, right? So this is a different method that will give us a little extra time to do that. I see two hands wanting to comment. Stephen, you comment, and then Adele Buckley.
Yes, just a quick thing. We need a few more numbers, and the key thing is to work out how much energy is reflected by a cloud drop, and that depends on how much energy is coming into it and what its diameter is and how long it lasts. And you can compare that with the amount of energy you need to make the condensation nuclei, of which the cloud drops had been growing on. And that depends on the surface area of the cloud drop and the surface tension of the seawater. Okay, it's not very efficient yet, but those are the two numbers you start with. And if you look at those two numbers, the difference, the ratio of them is quite enormous. I mean, it's 25 billion. So there's no other mechanism that I can think of that has such enormous energy ratio. I suppose you could think about a detonator that lets off a nuclear bomb, but we're trying to control, I've got a number here, we're trying to control an energy flow that's 100 times the American electricity consumption. Okay, and you need to have this incredible leverage in order to do that. And we can do that because of the surface tension to reflection ratio.
Thank you. Okay, Adele, let's have you ask a comment before I go on to Paul.
Okay. I have kind of a long list of questions, but I might ask, once you had the artificial white cloud in place, how long would it last? So that's one.
It lasts until it rains or snows.
I see. Well, I just read an article yesterday that there's expected to be a lot more rain in the Arctic instead of snow. because because
Well,
of
whatever, but it's that
climate
that
change.
washes it out. Yeah.
Yeah. So, well, also, Meta likes to envisage all of Hudson Bay as a kind of nice little place, but it's actually huge. How many stations would you possibly need to even begin to deal with forming ice in Hudson Bay?
Well,
And then finally, well, not finally, but anyway, just so you can answer the questions. I wonder who is working on this area in Canada that could work with you.
The calculation depends on how much energy is involved with the rate of melting of the ice. Now, for the Arctic, when I first looked at this, it was 25,000 tons of ice a second. It's a bit lower than that now, maybe because there's less to melt. And if you know the weight per second of the ice that's being lost, and you know the latent heat of freezing of ice, you know how many joules you've got to deal with. And then if you know what the solar energy coming in is, you can work out how much you need to change that by in order to give you the missing joules. And fortunately, for a short time, there's actually more solar energy coming into the North Pole than into the equator, because it's coming in over 24 hours. But you can, if you know those numbers, you can work out how many nuclei you need to spray to do it. I will send you the calculations, and you can adjust any of the assumptions I put in, and you will see what it is. But it is, you'll be surprised at how small it is. And it's because of this enormous ratio of the energy to make a drop and the energy that it will reflect. And they'll be there. They fall very, very slowly. So they'll be there until they're washed out by rain. And that will be maybe 1 or 2 or 3 days. In some parts of the world, it will be a bit longer, but that's roughly the time. So you have to keep doing it. And maybe that's a good thing, because it allows you to control and stop when you've had enough.
Mm-hmm. Okay, Adele, is that adequate, or you want?
Well, I guess I wonder if these clouds are near the shore, and can you then envisage they're there for a long time, and there's no sun in the communities near the shore, and they don't like that?
Well, we're trying to change the reflectivity by probably 5%, because we can't do it everywhere. If we did it everywhere, we'd only be 0.5%. So we'll say we've got to do it for 5%. Now, if you draw a series of bars of different grey, I can send you one where I've got 20 bars, and they've got a 5% difference in contrast between each bar. And the test is, how many bars do you have to see which way the gradient is? And most people need 3 or 4 bars, which means that they can't detect a change of less than about 15 or 20%. So you wouldn't notice at all that the clouds were a little bit whiter.
Okay. And I think she asked how many stations. I think you were suggesting maybe 4 different stations, and these can be simple things like you could bring in a container, these ship containers things, and plant them on the shore with some sort of wind turbine to power the nozzle and the other electronic equipment, and hire local indigenous persons to monitor each of these stations, which would be placed wherever it would be appropriate in order to freeze the local ice that the local people want to have restored. Am I correct about that, Stephen?
Yes. Well, you've got the wind blowing the spray along a long line, quite a narrow line, and you'll be getting cooling all the way along that line. And that could be halfway, maybe more, across the bay. And when the wind changes direction, it'll cool somewhere else. And what we would do would be to look with a satellite at the patterns of clouds, and we would need to get perhaps 100 different images of the satellite, and we would align them to suit the wind direction, and then we would just add them up, and you can then see by averaging at least 100 satellite images that there'd been a change in the reflectivity. And I can send you some calculations where we're simulating this, and you wouldn't see it on any one of the images, but you would see it if you could align them and add them together.
Okay, Adele? Let's, if
Not
okay.
quite. I just wondered, is anyone in Canada working on this or working on something similar that you might work with? Obviously, you're not located here. And if you were to set up some kind of trial, that would involve you doing lots of travel to remote parts of Canada. That doesn't sound very pleasant.
It's got to be done by Canadians, and there will be some work that will need people who are actually living there all the time. And what we would need to do would be to train them how to look after and check and report on how the spraying was going. So we'll be doing a bit of engineering training as well.
I know that this would be largely Indigenous people, and this would be great to give them some job because most of them are unemployed now. But Peter Wadhams, I think you were instrumental in setting up a very sophisticated marine laboratory in Churchill, Manitoba, right? And that would be, if you'd speak to that as a location for to be the headquarters for this research project.
Yes, because if we're talking Hudson Bay, then the only laboratory, really sea ice laboratory in the Hudson's Bay area is this one that was built quite recently. In fact, they haven't finished building it yet, for the University of Manitoba. So I think my only role was to vote in favour of spending Canadian government money on that rather than something else. And the first director was a real ball of fire called David Barber, very, very good scientist. But unfortunately, he died this year. So I'm hoping that they can get themselves sorted out so they can carry on. But it's a wonderful lab. It's open to the bay, so you can do experiments where you're doing things to the ice, doing things to the water in the bay, and it's linked in with the rest of the water of the bay, and so it's very, very nice laboratory. It's owned by it's the University of Manitoba, but they have lots and lots of people, visiting scientists coming in. So I think that if they can be persuaded to make that one of their major projects, that would be a very nice base for some of the work that
I noticed
we would want to be far enough away that we didn't get any contamination from whatever power generation they've got. So if you can think of a long plume of smoke coming out of the lab, we want to be to one side of that.
Yes. Right. Yeah.
Well, they certainly have a large staff. I looked it up on their website, and they have a lot of professionals working there. Okay, I want to go on and talk to Paul Beckwith, because although I've had conversations about this topic with Stephen and Peter before, I haven't really talked to Paul about it. But you're certainly the expert on the Canadian Arctic, among other things. So chime in and give your thoughts about this matter, Paul.
Okay. Well, first of all, I think this is a great idea. I think this is a great project. I think we could learn an awful lot from it, and actually even preserve some of the ice in Hudson's Bay. A couple points I'd like to make is, marine cloud brightening has gone on for years and years inadvertently, because any commercial ships that traverse the ocean put up aerosols and particles from their smokestacks. And these aerosols and particles from the ship tracks modify the clouds and the radiative forcing in the lines of clouds. So a very recent paper, which I just did a video on, called, Oops, Global Dimming is a lot more significant than we thought. Okay, the idea of global dimming is that we know that the radiative forcing from greenhouse gases is somewhat offset by the amount of aerosols in the atmosphere, both through a direct effect and an indirect effect. So the direct effect is that these aerosols block some of the sunlight coming in and cause a cooling on the surface. And the indirect effect is that these aerosols act as cloud condensation nuclei, increasing the low-level cloud cover, blocking some sunlight, causing some cooling. So the net effect of these two direct and indirect radiative effects is thought to be something like minus 1.2 or 1.4 watts per square meter. Now, all the research, and that number is often determined by these experiments on these ship tracks, because we can measure the water vapor in the atmosphere from satellites. We can measure the clouds, and we know where the ships go. Okay, their passage is very well known, their course. So if we take their course and then we use the prevailing winds to move the ship tracks to a different location based on the prevailing winds at the time that the satellite passes overhead. So we can take the location of the advected cloud tracks and we can correlate them with the satellite data, which measures the reflectivity. So we can get a number on, what these, how much radiative forcing is being offset by the so-called global dimming or aerosol effect. Now, a recent paper that just came out, which I discussed in detail in my video I posted just a couple of days ago, says that number, what we thought the negative radiative forcing was, is actually a lot larger than we thought. And the reason is because they were only using visible ship tracks that they could see on the satellite, but the ships are moving along their course and they're putting out these particles, and more often than not, there's no clouds above the ship tracks. The particles are put in the air, but no clouds develop. So when you account for that effect properly, the radiative forcing offset, or the global dimming effect, is about 40 or 50% larger than the mainstream number, the present science. This is a huge factor, because what it means is the climate models need to be readjusted with the proper numbers. It also means that the equilibrium climate sensitivity, which is the warming we would expect with a doubling of CO2, it means that number is worse than we thought. The temperature will go up more. The really good thing is it means that an effect, the work that Stephen Salter is talking about, the deployment of these aerosols, will have an even larger effect than he even expects, perhaps, but certainly more than mainstream science expects. Now, this is one paper, but it was very well done. It needs to be confirmed. The aerosol cloud interaction is one of the largest uncertainties in climate science in terms of getting decent models and stuff. So I would argue that an experiment, the work in Hudson's Bay, for example, the deployment of such systems would allow us to get much better numbers on the aerosol cloud interaction, and it would allow us to greatly improve all climate models, and it would allow us to get a much better handle on equilibrium climate sensitivity. The other thing is you would want to, having a shipping container type lab that could be with a wind turbine to power it, could be put on a location and could actually be moved if we wanted, by, say, a heavy lift helicopter or something. So it could be moved to whatever location we wanted as part of the experiment. also, clearly you want it to be upwind of Hudson's Bay. So typically the prevailing winds, blowing from west to east, you would want to locate these four units on the western side shores of Hudson's Bay. Further north, Churchill's down near the bottom of the bay, sort of. You'd want them up further in remote regions, but they're remote to us. I mean, there's people living up there, indigenous people living up there. So, yeah. So I think it's a fantastic idea, and I think it will improve our knowledge of aerosol cloud interactions, which is the largest uncertainty in climate change. And, it will, I think, First Nations people that have their lifestyle restored by sea ice, and the seals and the polar bears, et cetera, would be a very good thing. I'd also like to point out one other thing. Going the route of the indigenous people is a fantastic idea, because we don't necessarily have to get the buy-in of the Canadian government. We just have to get the buy-in of, groups of First Nations that live along Hudson's Bay, and a source of money. And I would argue there's a precedence for this in 2002, Russ George had contracts with First Nations people of Vancouver, Haida Gwaii, and they got funding, they got all the permits and approval from the Canadian government, and they went and they put iron. They put iron in the ocean off the coast of Vancouver, which stimulated phytoplankton. Salmon was at record levels of runs the year after, and then that was before the Canadian government decided that they wanted to close this thing down. But they didn't need money or approve; they just needed permits. It was the actual First Nations groups that wanted the project to be done to restore their salmon fishing. So there is precedence of this being done through that mechanism, using First Nations buy-in as opposed to so it's much less people you need to convince that this is a good project, assuming you can get the funding from somewhere.
We can also leave the wind turbine behind when we finished.
Yes.
I'm hoping to get in touch with some leaders of Indigenous people living on the west side of the Hudson Bay. Hudson Bay, somebody told me yesterday that you could take the entire British Isles and put 5 of them into Hudson Bay. It's that size. So the people living on the east side are not necessarily familiar with the people living on the west side, but I expect it's the people on the west side in Manitoba and Ontario that we would want to deal with most, and who would be asking us to put the ice where they want it. And so we would need to be in touch with them. And I'm not acquainted with any leaders. I hope that there is some sort of network or movement or organization of Indigenous people already existing, so that we could contact them, rather than we're not in a position, obviously, to organize their interactions or to deal with them separately. So if you, by the way, Paul, or anybody else, if you're familiar with any organization that is working with groups of people in that area, then let me know. I have just
I do know some people in the Winnipeg area that work a lot with First Nations in all different regions of Manitoba. Of course, Churchill's in Manitoba. The other thing, there's a lot of other benefits of trying this project, and there's huge amounts of coastal erosion from increased wave action in Hudson's Bay with lack of ice. So if you restore ice along bays and some coastlines, you can prevent this coastal erosion from occurring, which is actually destroying some First Nations settlements, et cetera, along the coast. And I'm talking about huge amounts of coastal erosion, like tens of meters, 20s, even hundreds of meters per year in some cases. Big storm comes through Hudson's Bay, and it does tremendous coastal damage because of the lack of sea ice on the bay.
Well, there's an additional thing that that Stephen sent me a couple of weeks ago, an article with a map showing that the coastal region around the southwest part of Hudson Bay is a wetland, largely peat, and it has recently been emitting large amounts of methane. So that is another reason to believe that if we did freeze that, the coastal area of the bay, that this would reduce the melting of the permafrost in the wetlands and reduce the emissions of very terrible emissions of methane. Does anybody know? I don't have that at hand today, but I might be able to find that map if anybody knows anything about that movement, because it is apparently quite alarming.
Now, just an aside is, if you want to get a feel for the size of Hudson Bay, it's just off the corner of Paul's armchair.
Okay.
Churchill's up here. Yeah, I thought Churchill, my geography's off. Churchill is where I'm pointing the pen at.
Yeah.
So there's Hudson's Bay right here. This is James Bay. And, the winds are mostly west to east. So you'd want stations, up probably, spaced here. Maybe one in Churchill, maybe one just south of Churchill on this stretch. It depends. I don't know, Stephen, have you looked at the aerosol concentration typically over Hudson's Bay at all?
I don't have a number for it, but I will try and get it. Yeah.
Because, from the satellites, because, is it a viable place? You might have to spray with a lot more aerosols because, there might be some aerosols blowing naturally off the land.
Well, the air will be very clean if it's just been raining or snowing. So there may be times when it's too dirty and times when it's fine.
Right.
Another interesting thing is that the water in Hudson's Bay is less saline than the general oceans. And that actually is to our advantage, because what matters is the mass of salt in the nuclei. So if you have fresher water, you have to have bigger drops, and it's the making very small drops that's the technical challenge. So we've got a nice reason why we would like to use rather fresh water. We need the salt in the end, so must have some salt, but the less we have, the easier it is to make the drops. The number of nozzles that we need is really enormous. We make them in a silicon wafer like a microchip, and we get 200 million nozzles in an 8-inch wafer. And the ships I'm using will have 30 of those wafers. So that'll tell you we've got an enormous number of nozzles. But microfabrication people don't mind very big numbers, provided everything is very flat.
Also islands here. Okay, there's Belcher Islands down here. Mm-hmm. There's an island down here. There's some islands up here. I don't know if there's some islands up in this region, but you don't necessarily have to put the stations on the coastline. If they were pretty autonomous, they could go on an island, and it would be probably a better thing to do.
As long as the air is clean, it doesn't matter, and it could be clean because it's been iced over and snowed over.
Right. So it's just another thought.
Yeah.
Now, your idea is that you would use wind turbines that would power the whole thing, right? You spray these things using the energy from wind turbines that you can just tow in there. And tell me how I know Adele has questions, so I'll defer to her, and then I have another question. Adele, yes, what's up?
Well, I guess I'm interested in the time frames. Will it be anywhere near soon enough? And supposing that miraculously you raised money for a demonstration project, you still have to, you can't really start until you have the money to build multiple nozzles, which, certainly it seems to be many of them. Who will make them? Then how long before, in the ideal world, from the day you have money till the day you are actually spraying on Hudson Bay?
I would guess about 5 years if you had plenty of money and if you got 0, it takes a bit longer. But 5 years is a guess.
That's the first trial. It's not
Yeah.
it's not a set of stations.
And you would probably have most of the answers in the first year, because we want to do the,
So
we have to do this in the summertime.
Then you decide, okay, we're going to do it a lot more of them.
Yeah.
So now we get to the point where perhaps 10 years have elapsed.
Well, it depends on the
now finally
resources, of
someone
course.
says, yeah, let's try this in the Pacific. Anyway, time is marching on, and by this time we're at 2035 or something. And is it too late to be doing this?
Well, what do you mean too late, I guess?
Well, the longer we leave it, the more important it is to do it. I don't think that well, I suppose if there's a complete collapse of civilization so that we can't do it anymore, then that's one of the boundary conditions. But I've been working on it since 2004, and please don't blame me if it's late. The progress to cost ratio, which is what really matters in these things, is infinite, because I hadn't had any money.
Mhm.
Well, so local people would continue repeating the spraying as they see the conditions and as the satellite information comes to them. I think that's approximately right. But I wonder if the ice is sort of stable in the sense that you could actually use it in the traditional Inuit way, that it would be dangerous, because obviously there would be times when the ice wasn't stable, it was continuing to try to warm. There would be a lot of concern, in my view, of like going out on the ice to do anything.
Well, the guys that live there will be very, very good at judging whether it's safe to go on the ice. I mean, that's they need that to survive. So I would let them decide whether it was thick enough to walk on or take a sledge on.
They'd have to rely on their colleagues, if you like, to, okay, we have to keep doing this, or the people that are out on the ice will have trouble.
I think we could find a way to measure the ice thickness, perhaps even measure it from a satellite. Maybe Peter Wadhams would tell us about that. But we ought to be possible to tell them what the ice thickness is and let them decide.
We can measure the thickness from satellites, the latest satellites. The thing that throws it off is when there's melt ponds on the surface of the ice that can throw those numbers off. So as the ice is, in the spring, perhaps the accuracy is not as good as it would be, in other times. Like the satellite can measure freeboard, for example. It can measure the distance to the ice and then the distance to open water right next to the ice, and from that difference, can measure the freeboard. It knows how thick the ice is.
Yeah, the native people are already having a lot of grief because of the melting ice. Of course, it's frozen in the winter, and then it's not behaving the way it used to 30 years ago, and therefore it's more dangerous for them. And also, there are other things about their livelihood being affected adversely. The seals used to be, because of the salinity of the water, I believe, or temperature or something, the seals would float. So they'd harpoon a seal and then they'd try to, drag it into the boat. But they can't do that anymore because the seals now sink before they can reach it. And another detrimental thing has to do with the polar bears, which are not reproducing normally. Most of the pregnant polar bears don't give birth anymore. I don't know what happens, but it's detrimental. So they need ice. I mean, we need to restore ice for the livelihood of the people living in that area. So they have a strong claim for that, and we have to work closely with them. It's not our business to tell them what they need. They tell us what they need and where they want their ice, and we'll see what we can do about it.
And another factor is if you're cooling a large portion of Hudson's Bay, that cold air mass does move over land, right? So you will actually cool surrounding land areas
Mhm.
I'd like to hear something about what happens to the sun during all of this, because I
Well,
think human beings need sunshine for their own mental health. And are we anticipating not seeing the sun, or what are we doing?
the difference would be undetectable. They won't know. There's an enormous difference between summer and winter. So the tiny difference in the 0.5% maybe to maybe 5% is not detectable.
That sounds reassuring. How many stations around Hudson Bay, just roughly, would you think would be desirable and the best of all worlds?
Well, we need to do it when there's in their midsummer. That's when most of when we get the best effect from increasing the reflectivity. So we'll be doing it May, June, July.
So I'd say one station to start off. That's all you need. Put one station in.
One station, it's going to
detect a big difference, and then there's a scramble to make as many stations as possible because it works so well.
Yeah.
Well, but the
We learn a lot from the very first one.
Mhm.
So one station would be, you said 4 would be about 30 million. Would you say about 10 million for one?
I think the difference in numbers, I don't think it's proportional to the number at all.
Okay.
I think doing anything is going to be 20 or 30 million. And whether you want 5 or 10 stations really isn't much extra.
Mhm.
But those costs are actually very tiny. They're big for science, but they're tiny compared to, say, the money being squandered every day by the British government on various weirdo projects. But,
Well, I'm hoping that we can talk to the Canadian government into this. I don't see myself going around with a can hoping people will put their pennies into it and collect the money for this independently. If the government isn't ready to support it, I don't see how. I mean, we can't. I don't see the Canadian Pugwash Group doing it. So, but I think it's a very reasonable thing if we show the financial and other benefits. And in fact, since Biden has put through this Inflation Reduction Act with a lot of money for climate change interventions in the US, all of a sudden there's new pressure on the Canadian government to step up and do more as well. Canada has not been putting that kind of money into trying to reduce the climate crisis. And this plus 3 other measures that I have chosen in my own infinite wisdom about these matters, I have chosen ones that I think can be done within 5 years. And all of them could be sponsored by or promoted by the Canadian government. This one would probably be one of the most, if not the most expensive, but something like $30 million is affordable. The Canadian government can handle that without any trouble, right?
The biggest money return would be moderating hurricanes. People in Florida will agree with this at the moment. And what we would do would be to have ships cruising in the Atlantic between the Gulf of Mexico and Africa. The hurricanes start over on the African side, and they would be cruising around and measuring the sea surface temperature and trying to reduce it to the point which was a temperature set by the joint views of all the governments in the Gulf of Mexico. And if you look at the benefit to cost ratio of this, knocking the sea surface temperature down by about 2 degrees would have prevented the recent hurricane that they've had in Florida. And the benefit for that is absolutely enormous compared with the cost. So it's thousands of times cheaper to have these vessels cruising around and moderating hurricanes than to pay for all the damage.
Absolutely. Okay, our time is up, but I want to suggest that those of you, especially the Canadian Pugwash Group, if you're Pugwashites are watching this and you have thoughts or questions, go to our website as soon as I get this thing posted. I edit these shows, and there's hardly anything to do to this one to edit it. I'll put it up tonight on the website to savetheworld.ca, and you can find it there. I think it will be number 509 is the number of the show. I've done 508 shows before this, and you can search for 509 and look at this, watch this video if you haven't had a chance, or if you want to see it again. And if you have questions or comments, there's a comments column below. So I suggest that you post your ideas, your comments below there, and we will get people answering, because there's a way you can reply. So you have a real conversation going on that comments column. So is there anything else quickly that needs to be said before I say goodbye?
I would just like to say that shoreline erosion, if it is a good and large effect, could be a very important way of promoting this.
Mm-hmm. Okay. Good to know. Thank you all. I think this is extremely helpful, and let's hope that other people agree with us that it is really worth exploring. At any rate, I think the Canadian Pugwash Group would do well to form a team of people to look into this and make sure that we have not missed anything that is relevant to making decisions. Thank you all. Bye.
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 Project Save the World produces at least 2 of these shows each week. This one is number 509. You can watch them or listen to them as audio podcasts on our website, tosavetheworld.ca. People share information there about 6 global issues. To find a particular talk show, enter its title or episode number in the search bar, or the name of one of the guest speakers. Project Save the World also produces a quarterly online publication, Peace Magazine. You can subscribe for $20 Canadian per year. Just go to pressreader.com on your browser, and in the search bar, enter the word peace. You'll see buttons to click to subscribe.